all of you. Dayashankarji, I just wanted to know what is the background of the students?
Sir, most of the from geography background and from education and nutrition,
Home science.
Science, home science. Participants are requested to mute their system whenever needed. Please unmute yourself and ask the question to our person, resource person.
Sorry, there was some important call from the office. Yeah, I was just asking about the background of the students. Anybody want to share some? Somebody was saying home science, somebody was saying economics.
Yeah, home science, science, food and nutrition.
Okay.
Zoology.
Geology, yes.
Social work.
Social work, okay.
Most of the participants are from the geography.
Social science, geography.
Science, yeah.
So social science, geography, geology. So, okay. Because why I ask about the basic background, so that I can start with the basics only. I'll start from the basics and try to give you the idea about the nature and types of variables, then how to enter data in SPSS, how to label different kind of variables, how to split files, how to select cases, and how to import files from some other packages like Excel to SPSS. So all these things I'll try to cover up, and if you will be with me, I'll make sure that you will not face any difficulty in learning SPSS. And SPSS is a very, very important tool these days, because other softwares, they require programming, and most of the social science people, they are afraid of the programming, and they want certain results which are menu driven. So that's why SPSS is a very, very important software. Okay, with this background, let me start with, share the screen. Just a minute. Hopefully you can see my desktop. Yes, please. Is the desktop visible?
Yes, sir.
All right, all right, all right, okay. Let me start with the very basics of statistics. First of all, in 10-15 minutes, I'll cover research methodology part, and then I'll give you some idea about statistics, and then later on we will come to the SPSS, right? But if you will be with me for up to 7:30 today, I think, then we will be able to cover most of the topics, including graphics, descriptive statistics, everything, including research methodology. All right. Now, if you look at the nature and types of data, you see, no research is possible unless you understand the nature of the data. If the nature of the data is not clear to you, you may apply certain wrong techniques, and your inference could be totally wrong. So if you look at the nature and types of data, first of all, nature of data, it is basically of two types. Either it is called structured data or it is called unstructured data. Now, what do you mean by structured data? Structured data is the one where features can be easily extracted. For example,
sorry,
yes, please.
Okay, so now your skin is visible.
It's not visible or visible?
Sir, now visible. Earlier it is not visible.
Okay. So if you face any difficulty, you can just interrupt me right in. Okay.
Okay, sir.
All right.
Okay, sir.
Yeah. Okay. Nature of data. So if you look at the nature of data, any type of data, either it is called a structured data or it is called unstructured data. Now, what do you mean by structured data? Structured data is the one where features can be easily extracted. For example, if I give you, let's say, height of 50 students or weight of 100 students, then you can easily compute its mean, you can compute median, you can compute mode, you can go for the minimum value, maximum value, range. You can also look into skewness, percentiles, quantiles, deciles, right, kurtosis, etc. So all these things can be easily computed if some certain numbers are there. So this kind of data, which is already in the numeric form, comes under what is called structured data. But what happens sometimes, the data is not exactly in the numeric form, but it's easily convertible into numeric form. For example, look at gender. The gender is not numeric as such. It's male and female. But I can always give certain codes. Say male as 1, female as 2. So it's become numerical. And then go for the counting of ones, counting of twos. Counting of 1 means counting of males and counting of 2 means counting of females. But it is in the numeric form now. Similarly, socioeconomic class can be written as lower class as 1, middle class as 2, upper class as 3. Right? So there are certain data which are not exactly in the form of numeric, but they can be easily convertible into numeric, like gender, like socioeconomic status. That type of data also comes under structured data. So what is structured data basically? It is already in the numeric form or it's easily convertible into numeric form. That also comes under structured data. Then there is unstructured data. What is unstructured data? Unstructured data is the one where features are not easy to extract. For example, everybody is using WhatsApp. There are hundreds, thousands of messages every day. There are pictures, videos, messages. Now, if at the end of the day, I ask you to convert the entire information of WhatsApp messages to numeric, I don't think anybody can do it, right? But information is there. They are talking about something. Somebody is talking about something. Information is there. So this kind of data, which is not easily convertible into numeric form, comes under what is called unstructured data. So you look at any social media sites, you look at your email, you look at your research papers, it's not easily convertible into numeric form, but information is there. So this kind of data is called unstructured data. Now, people also talk these days about big data. Big data is nothing but a combination of structured and unstructured data. Combination of structured and unstructured data. All right. So basically, these are the nature of data. It is easier to deal with structured data, very difficult to deal with unstructured data. And 2 of my students from statistics and 2 from bioinformatics, they have completed their PhD on unstructured data. I mean, we have used certain advanced techniques for unstructured data because it's required big data techniques like machine learning, artificial intelligence. Otherwise, it is not possible. All right. But as far as this workshop is concerned, we will be focusing on only structured data. Structured data means which is in the numeric form. So if you look at the structured data, it is basically again of 2 types. Either it is called categorical data or it's called measurement data. Now, what do you mean by categorical data? Categorical data is the one where measurements are in terms of categories. For example, gender. It's category male and female. I can write male as 1, female as 2, or you can write female as 1, male as 2. Doesn't make any difference, right? But what is the measurement data? Measurement data means some kind of instrument is being involved in measuring something. For example, you can measure height, you can measure weight, blood pressure, cholesterol. So you require some kind of instrument. But sometimes you don't require any instrument, but it could be a measurable quantity. For example, to measure age, you don't require any instrument, but age can be measured in years. Then you can add months, even days, minutes, and seconds. So it becomes a measurable quantity. All right. So hopefully the difference between the categorical data and the measurement data is clear to you. These are the examples of the categorical data. For example, hair color could be brown, it could be red, it could be black, right? It could be, I didn't put sometimes white there because people sometimes get depressed, right? Our entire body is made up of 4 types of nucleotides. They are known as ATGC. I can write A as 1, T as 2, G as 3, C as 4. And you have heard about that there is a new mutation of the COVID-19. New mutation is because these are the mutations in the nucleotides, ATGC only, right? Then eye color can be coded as 1, 2, 3, 4. Gender can be coded as 1 and 2. Disease, mild, moderate, severe, you can write 1, 2, 3. Genotypes, depending upon which one is dominant, which one is recessive, you can write 0, 1 and 2. So all this kind of data, which is in the form of label, easily convertible into numeric form, comes under what is called the categorical data. And this is self-explanatory measurement data, already explained, cholesterol level, height, age. Now, if you look at any kind of measurement data, it is basically of two types. Either it is called the discrete measurement data or it is called continuous measurement data. Now, what do you mean by discrete measurement data? Discrete measurement data means if certain isolated values are present in your data, then it is called a discrete measurement. For example, number of members in a family. Number of members in a family may be 5 members, 3 members, 4 members. I cannot say number of members in a family is 2.9 or 2.8. It doesn't make any sense. Number of errors in the book, number of students present in the class. So if it is about the complete integer or it is capable of taking only certain isolated values, then we say that it is a discrete measurement. And what is a continuous measurement? Continuous measurement like height. Height is capable of taking any value within certain specified range. Height could be 157.5, 157.57 centimeter, 157.578 centimeter. You can add third, fourth, fifth decimal depending upon the accuracy of your instrument. And let's say height can take any value between 145 to 175 centimeters. So it is capable of taking all decimal places. This kind of data is called, measurement data is called a continuous measurement data. So hopefully the difference between the continuous and the discrete is clear to you. Okay, now this is something important. So far I mentioned that there is a categorical data, there is a measurement kind of data. Now measurement scale is a very, very important concept in the sense whenever we enter the data in SPSS, then SPSS will ask you whether your data belongs to the categorical in nature or measurement data. And if it is, then which kind of scale you are using. Either you are using nominal scale, ordinal scale, interval and ratio. So I will explain you these scales before coming to the part of the data analysis. There are two scales which are associated with the categorical data. One is called the nominal scale, another is called the ordinal scale. Nominal scale, ordinal scale. Please remember these two scales are for categorical data, nominal, ordinal. And again there are two scales for categorical data and these two scales are interval and ratio. Interval and ratio for measurement, nominal and ordinal for categorical data. Please remember these terms or maybe you can note down also. Now first of all I will discuss what is the difference between these scales. First of all I will pick up the categorical data. There are two scales, nominal and ordinal, and give you certain examples. For example, nominal scale for categorical data. Look at the first line. A type of categorical data in which objects fall into unordered categories. What does this mean? That means you cannot order the categories. For example, if I am looking at gender, it's male and female. But I cannot say that I will write male first and female later. Or you can write female first or male later. You cannot do like that. You cannot order them. Everybody is human being. You can write male as 1, female as 2, or you can write female as 1, male as 2. Doesn't make any difference. So bottom line is that if there is equal preference to each and every category, let me just repeat, if there is equal preference to each and every category, then we say that our data belongs to the nominal scale. Right? All of them are given equal weightage, like gender, like religion, Hindu, Muslim, Sikh, Christian. Everybody is human being, right? So you can write in any order. So this kind of data where all the categories are given equal weightage, then we say that our data belongs to the nominal scale. Examples of nominal scale: gender, color, where do you live. So all these are examples of nominal scale. Then again for categorical data, there is another scale which is called ordinal scale. Now what is ordinal scale? A type of categorical data in which order becomes important. That's the only difference between nominal and ordinal. In case of ordinal, there is no order. But in case of ordinal scale, categories can be arranged in order from the lowest to the highest or highest to the lowest. For example, if I am looking at, let's say, socioeconomic class, lower class has 1, middle class has 2, upper class has 3. But 1 means the lower income group, 3 means the higher income group. So you can arrange the categories in order. Similarly, if I am looking at education categories, education category means primary school, middle school, high school, graduate, postgraduate. So all these categories can be arranged in order from the lowest to the highest. So that's the difference between nominal and ordinal. So one can arrange the categories either in ascending or descending order of magnitude. But either you are dealing with the nominal scale or you are dealing with the ordinal scale, numerical distance between any two categories does not have any significance at all. Does not have any significance at all. For example, let's say I'm writing male as 1, female as 2, and subtract 2 minus 1. It doesn't have any meaning. Similarly, in socioeconomic class, so lower class has 1, middle class has 2, upper class has 3, subtract 3 minus 2 or 3 minus 1. It doesn't have any meaning at all. So remember, whether you are dealing with the nominal scale or ordinal scale, numerical distance between any two categories does not make any sense at all. Right? These are the examples of ordinal scale. How do you feel today? Today is the first day of the workshop. So I can very well imagine how do you feel today? Very unhappy, unhappy, okay, happy, very happy. So which category you belong to, you can judge yourself. Of course, if you will be 3 and above, I will be happy. If you are below 3, then obviously this workshop may not be for you. But anyhow, the idea here is you can arrange the categories in order from the lowest to the highest. How satisfied are you with our services? So at the end of the entire workshop, you will be given some feedback pro forma in which you will be given some questions very unsatisfied to very satisfied. That means from the lowest to the highest, the idea here is you can arrange the categories in order. That's all about the categorical data. Categorical data is always in terms of two different scales, nominal and ordinal. And today I'll give you one exercise also where you have to judge whether your data belongs to the nominal or ordinal scale. That's all about the categorical data. Now we move on to the measurement kind of data. Measurement data is also having two scales, interval and ratio. Now first of all, I'll cover the interval scale. In interval scale, look at the first line. In interval scale, mathematical operations may not be valid. There are many types of data where mathematical operations are not valid. Let's say some beauty contest is going on and there are judges say giving score out of 10. Let's say first person gets a score of 8 out of 10 and second one gets a score of 4 out of 10. Now if you divide 8 by 4, your answer is 2. But you cannot make a statement that the person whose score is 8 is exactly twice the beautiful than the person whose score is 4. Can I make such type of statements? I cannot. Let's say one student has scored 90 marks in a test. Another student has scored 30 marks in a test. Divide 90 by 30, answer is 3. But I cannot make a statement that the student whose score is 90 is exactly 3 times the intelligent than the student whose score is 30. You cannot make such type of statements. You may be intelligent in sports or in some other category, right? And moreover, in interval scale, 0 means the quantity exists. Quantity exists. For example, if I say temperature 0, it does not mean the temperature is absent. It is still better than -5. If I say somebody has scored 0 in a test, it does not mean the person is not intelligent at all. Maybe on a particular day, his or her performance is not up to the mark. Next time he or she can score better, right? So 0 does not mean the absence of character. So examples of interval scale, beauty score, intelligence score, temperature, etc. They're all measured on interval scale. Hopefully the idea about the interval scale is clear. And moreover, in interval scale, 0 always has some kind of meaning. For example, temperature 0 has a meaning. Score obtained by students, if it is 0, has a meaning, right? So 0 has a meaning in interval scale. That's why 0 is called an arbitrary 0 in interval scale. 0 is called an arbitrary 0. It doesn't mean the true 0. And to overcome all such difficulties which are there for the other scales, we come to the highest rating scale, and that is called the ratio scale. All mathematical operations are valid. All mathematical operations are valid. Means you can divide, you can multiply, you can do anything. For example, let's say one person is having weight 90 kg. another person is having weight 45 kg. Divide 90 by 45. Your answer is 2. But you can always make a statement that the person whose weight is 90 kg is double the weight of the person whose weight is 45 kg. Nothing wrong with that, right? Similarly, generally we say that the age of the father is 3 times the age of the son. The father is 45 years, son is 15 years, so it is 3 times. So you can divide, multiply, etc. You can do everything. But remember, in ratio scale, 0 means quantity does not exist, non-existent quantity, right? That's why 0 in measurement scale or the ratio scale is basically called true 0. For example, if I say height 0, that means height doesn't exist. If I say weight 0, weight doesn't exist. Age 0, age doesn't exist, right? So that's why if you are still confused between interval and ratio scale, just look at 0. If 0 has a meaning for your variable, it will go to the interval scale. If 0 doesn't have any meaning for you, it will go to the ratio scale. As simple as that, right? So with this background of different kind of scales, let's move into the summary of the different kind of scales. So here I have put all the 4 scales: nominal, ordinal. The first 2 are for categorical and the last 2 are for measurement data. Now, most of the time in calculations we are involved with the counting. Counting means counting of males, counting of females. So that is called frequency. Now, if you look at nominal scale means I can easily go for the counting of male and female. That's nominal scale. Ordinal scale, you can go for the lower class, middle class, upper class, how many people they belong to each class. So you can go for counting. Similarly, in interval ratio scale, you can divide your data into small intervals, 10 to 20, 20 to 30, 30 to 40, go for counting. So counting is possible in all the 4 scales. But generally, how do we compute median? To compute median, we have to arrange the data in order from the lowest to the highest. But do you think it is possible to arrange the data in order in nominal scale? Can you arrange gender in that this is lowest and this is highest? It is not possible. So nominal scale ordering is not possible, but it is possible in ordinal, interval and ratio. Order of the value is known, that this is lowest and this is highest, or this is in between in ordinal scale, interval and ratio. Can quantify the difference. Already mentioned, the difference etc. does not make any sense in nominal and ordinal, but it makes sense in interval and ratio. Can add or subtract. You can add or subtract in interval as well in ratio. Can multiply or divide only in ratio. Have a true 0 only in ratio scale. So this is a summary of different kind of measures. Okay. This is again very important slide. Sometimes we deal with the same variable and you can put this same variable into different scales. Question is, how do you measure? Let's look at education as a variable. Now, education can be measured from different point of view. Number of years of education, type of education, level of education. How you are going to measure a particular aspect of the education will determine the scale. For example, if I measure by the type of education, such as private or public. Now, some people prefer private, some prefer public. It is individual choice. So your data will go to the nominal scale. And it can be put into ordinal scale when measured by the level of education. Level of education means primary school, high school, college, graduate, postgraduate. So all these categories can be arranged in order. So same variable education can be put into ordinal scale. Important point is, how do you measure? In this case, you are measured by the level of education. And if you go to US or UK, they will ask you about the number of years of education. 10 years of education, 15 years of education, 20 years of education. And the same variable can go to the interval scale, right? So same variable can go to different scale. Question is, how do you measure? Hopefully these things make sense to you. Who cares? Obviously, statistics people have to care that our data is on which kind of scale, because there are different statistical techniques for different kind of scales. For example, if you are using only categorical data, your questions are yes, no type, or socioeconomic factor like religion, gender, then marital status, then occupation, etc. They are all categorical in nature. then statistical techniques are going to be different. And sometimes we deal only with the measurement kind of data, like anthropometric parameters, like height, weight, blood pressure, cholesterol, skin fold thickness, chest measurement. So all this is a measurement kind of data. Then statistical techniques will be different. The important point is when there is a mixture of the two. Some variables are categorical, some variables are measurable quantities. Then how to look into the statistical analysis. And that we will discuss in this entire workshop, how to deal with when there is a mixture of the two. For example, let's say one variable is gender, which is categorical. Another variable is blood pressure. Now I want to correlate blood pressure with gender. Now I cannot do like Pearson's correlation coefficient or Spearman's, because one is a categorical variable. Those techniques are not applicable. Then there are different techniques, statistical techniques to deal with, which we will discuss. Now when people deal with the categorical type of data, they generally compute percentages, proportions, etc. Percentages, proportion, etc. Right? I mean, if you are given, let's say, categorical type of data, you can go for what is the percentage of males, percentage of females. Similarly, people also draw bar diagram, they also draw pie charts, etc. Nothing much they can do. But look at the last paragraph, which is written in red color. In fact, there is a call from the Professor Devash. हेलो सर, मैं सेशन ले रहा हूँ आपका ना यहाँ पे, आपका ही सेशन चल रहा है ये अपना गुप्ता, मैं शाम को बात करता हूँ आपसे. ओके. I received a call from Professor Devashish, who is the maybe I thought it is important, but he says I want to talk to you. Maybe later I'll talk to you. Okay. Is this clear what I'm explaining? Yes, please. Any response? Is that clear? Hello? Can
Yes,
somebody? Okay, all right, all right.
Yes, sir.
Look at the last look at the last paragraph, please. Whenever we deal with the categorical type of data, there are many techniques which you can apply. Even you can compute different type of correlations for categorical data. But these correlations are not Pearson or Spearman's type of correlation. There is a coefficient of uncertainty, there is a gamma coefficient, there is a tetra correlation, biserial correlation, point biserial correlation, right? Different type of correlation whenever we deal with the categorical type of data. And similarly, different regression techniques, which are called prediction techniques, logic regression, probability regression, logistic regression, which you will learn in this entire workshop. And most of them, they can capture your categorical data. Even statistical modeling like analysis of variance, one way, two way, etc. They can be covered for categorical data, but they are known as Kruskal-Wallis test, Friedman test, etc. All right? But a lot of techniques are there to handle the categorical data. And when people deal with the continuous type of data like height, weight, etc., then you have a lot of choices. You can compute mean, median, mode, skewness, kurtosis. You can draw histogram, you can draw box plot. Please remember, histogram and box plot, which I'll draw today, they are always meant for continuous type of data. While in my previous slide, I have shown you that bar diagram and pie charts, they are meant for the categorical data. Categorical data. Remember this thing. Okay, and look at the last paragraph. If you are dealing with a continuous type of measurement, then you can perform different type of statistical techniques. Broadly speaking, there are two important techniques. One is called parametric test, another one is called non-parametric test. And if your data satisfies certain set of assumptions like normality, independence, etc., we apply parametric test. But if data does not satisfy these assumptions, then we apply non-parametric test, which will be discussed later by someone else, parametric and non-parametric test. Okay. Now, before coming to the SPSS, let me give, because SPSS will give you output only. And if SPSS will give you output, then the interpretation is required. And if you don't know what is the meaning of skewness, what is the meaning of kurtosis, what is the meaning of percentile and decile, then you cannot interpret your data. If you don't know where to use mean, where to use median, where to use mode, then obviously interpretation will vary. You may get something which is not desirable, right? So that's why there are measures in statistics and they are known as descriptive statistics. Why the name descriptive is given? Descriptive means to describe the features of your data, to describe the features of your data based on statistical methods or mathematical methods. So that's why the name comes descriptive. I'll take a simple example. Suppose there is a basket in which 100 oranges are there. All right. Now I ask you to comment something on this. Somebody can look at the shape and size. Some them are of small size, some are medium size, some are big size. Somebody can say they are having different colors also. Some are more yellow, some are green, some are in between. What you are trying to do basically? You are trying to explain the features of oranges. But these are just 100 oranges. Suppose I give you 5,000 observations. Suppose I give you 5 lakh observations. Then the task becomes difficult. That's why we look into descriptive statistics, like mean, median, mode, right? So they are very helpful in describing your data. Now, for example, the first measure of center tendency, which gives you idea about the central part, is mean. Now, how do we compute mean? I'll not give you any formula. Mean means you add all the observation, divide by the number of observations, you will get mean. Anybody can do it, right? But there are certain problems with mean. Let's say I give you a data 1981 to 1990 population data is given to you. All population figures are available. Now I ask you to compute mean of this population. So what you will do? You will add all the 10 observation 81 to 90 and divide by 10, you will get your answer. But suppose 88 population is missing, there is a question mark. 87 is available, 89 is available, all others are also available, but 88 is missing. Now my question is, you compute mean. Now you are in big trouble with simple problem. You cannot compute mean even if there is missing value. You can compute mean of 9 observation, but I am asking to get the mean of 10 observation because 1 is missing. So even for simple problem, mean is difficult to compute, right? Then mean sometimes doesn't make any sense at all. Let's say most of your values lies between suppose 100 and 120, between 100 and 100 to 120. Let's say 99% of the values are between 100 to 120. And if you compute the mean, your mean will also be between 100 to 120. But suppose there is one observation which is 260, Now if you include this observation into also computation of mean, because of this one observation, your entire mean may shift to 160. While 99% of the observations they are between 100 to 120. Do you think mean is a right representation? I don't think so. So mean sometimes could be misleading. So mean cannot be computed if there are missing values. Mean doesn't make any sense if there are outliers present in the data. Outlier means some observation which is away from the main body of the data. Like 260 is very far away from other observations, which are all between 100 to 120. So it's an outlier. So there are certain problems with mean. That's why we look at median, right? Now, how do we compute median? We arrange the data in order from the lowest to the highest, and then compute the median. Let's look at the population figures, 1981 to 1990. 88 is missing, but I can always assume that population is increasing most of the time. In India, it will never decrease. So obviously, 88 population will be higher than 87. 89 will be higher than 88. So you can arrange them in order. Although at 88 there is a question mark. But if you compute the median will be certainly around about 1985 value. 85, right? So median can be computed easily, but not mean. Similarly, in the other set of data like 100 to 121 observation with 260, median will lie between 100 to 120, but mean may shift. So median makes sense, mean sometimes doesn't make sense. Then how to compute mode? Here's the definition of mod. The most frequently occurring value. The most frequently occurring value among the set of observations is called mod. The value which occurs most frequently. For example, 1, 5, 5, 5, 5, 7. So here if you see this data, 5 is occurring maximum number of times. So mod will be 5. Right? 5 is occurring how many times? 1, 2, 3, 4, 5 times. Right? So mod value is that value which occurs maximum with maximum frequency. Now suppose I change this data. Let's say 5 is occurring 5 times and this figure which is 7 is also occurring 5 times. Now you have the data in which 5 is occurring 5 times, 7 is also occurring 5 times. My question is, what is the value of mod? Some of you may answer that it is 5 plus 7 divided by 2. Answer will be 6. Absolutely wrong. Because look at the definition. Most frequently occurring value. 6 is not there in the picture also. It's not there in the observations. So 6 cannot be mod. But there are two most frequently occurring values, 5 as well as 7. So both of them are considered as mod. Remember, mean value is always 1. Median value is always 1. But mod may be more than 1. More than 1. Right? If there are 2 mods in your data, then this is called a bi-model distribution. If there are 3 mods in your data, this is called tri-model distribution. And tri-model and tetra-model, they are all known as multi-model distribution. Right? Now, if I change the data again, let's say every figure is occurring once. 1 occurs once, 2 occurs once, 3, 4, 5, 7. Every figure occurs one time only. There is no repetition. My question is, what is the value of mod? Some of you may say, all the values are mod. Absolutely wrong. Because look at the definition. Most frequently occurring value. There is no most frequently occurring value. Every value is occurring only once. So what should be the answer? Answer is, mod will not exist. Remember, mean exists, median exists, mod may not exist. Even there could be more than 2 mods. Okay? Hopefully, the idea about mean, median, mod is clear to you. Now, once we know mean, median, mod, then why to look at the variability or variation? Why to look at the variability or variation? Now, variation stands for the dispersion. Dispersion means how the observations are scattered from each other. Now, I'll give you a very simple example. You may be convinced that mean, median, mod can describe your data. Let's see, to up to a certain extent. Yes, that is true up to a certain extent, but not in total. Let me give you a simple example. Suppose this is your series 1 data and this is series 2 data. Look at this data, 1, 5, 9, 13, 17. This is 7, 8, 9, 10, 11. Take the sum of all the observations, sum will be 45. Also take the sum of these observations, sum will be 45. Number of observation in series 1 is 5. Number of observation in series 2 is 5. Now how do we compute mean? Sum divided by the number. So if I compute the mean, sum will be 45 divided by 5, 9. 45 divided by 5 will be 9. Okay. Now in both the series, mean is 9. Okay, here is my important question. I will not show you the data. I will not show you the data and ask you that if mean of 5 observation is 9, can you make out whether this has come from series 1 or series 2? Hopefully you cannot. It could be series 1 data, it could be series 2 data, because both the series are having mean as 9. But series are different, observations are different. That means mean cannot describe your data completely. There is something missing. And what is missing is called dispersion or variation. Look at series 1 data. It varies from 1, 5, 9, 13, 17. So a lot of variation is there. But look at series 2 data. They are very, very close. 7, 8, 9, 10, 11. Very close to each other. So if you see from your eye, you can easily see that variation is less here, variation is more here. But these are just 5 observations. Suppose I give you 500 observations, 5 lakh observations, 50 lakh observations, then you cannot see from your eye. Then that's why we need some mathematical measure to look into variation or variability, right? The simplest measure to look into variation is to compute range, which is the difference between highest and lowest. So if you look at the range, 17 minus 1, it is 16. If you look at the range here, 11 minus 7, it is 4. So series 1 is almost having 4 times. 4 into 4 is 16, so almost 4 times the range of the second. So you can say that series 1 is having more variation as compared to series 2. But range is not a very good measure of dispersion. It just depends upon two values. If your entire data is between 100 to 120, your range will be 120 minus 100, answer will be 20. But suppose one observation is 260, look at the range now. 260 minus 100, it will come to 160. Lot of variation in the range. So that's why range is not considered to be a very good measure of dispersion. What is the best measure of dispersion? The best measure of dispersion is called variance or standard deviation. Variance or standard deviation, right? Now let's look at why they are called the best measure of dispersion. To demonstrate, I'll give you simple logic that why variance is considered to be the best measure of dispersion. Now here, mean is denoted by x bar. Any observation in statistics is denoted by xi. So if you just concentrate for 1 minute and you will come to know why variance is important. Okay, as I mentioned in statistics, x bar is called mean. Any observation is denoted by xi. For example, in series 1, your x1 is 1, x2 is 5, x3 is 9, and so on. Similarly, in series 2, your x1 is 7, x2 is 8, and so on. Right? Now let me do a very simple exercise. Suppose I subtract mean from every observation. Mean from every observation means xi minus x bar. So your x bar is 9. These are your xi's. So 1 minus 9 minus 8. 5 minus 9 minus 4. 13 minus 9. 9 minus 9 0. 13 minus 9 4. 17 minus 9 8. Same thing you do it for series 2. Xi minus x bar. 7 minus 9 minus 2 minus 1 0 1 and 2. Now everything converts to, you see 0 is there in the center. 0 is there in the center. That means, and comparison in terms of 0 is always easy. So your picture will look like this for series 1 and series. This is series 1, which varies from minus 8 to plus 8. This is series 2, which varies from minus 2 to plus 2. So series 2 varies from minus 2 to plus 2. Series 1 varies from minus 8 to plus 8. Right? So you can see this is having a bigger line, this is having a smaller line. So where there is a smaller line, the points are closer to 0. If points are closer to 0, there will be less dispersion. If points are far away from 0 or the differences are far away from 0, there will be large dispersion. So that's why I converted around 0, both of them. That was the reason actually, because comparison in terms of 0 becomes very easy. But people from social sciences, from medical sciences, they are afraid of the negative sign. Our data was positive, how come the differences are coming out to be negative, right? So these statistics people are very smart. They say, okay, if you are afraid of negative sign, let's get rid of negative sign. How to get rid of negative sign? You scale the quantity. If it is minus 3, you scale that, it will become 9. Minus 3 into minus 3 will become 9. Let's square this quantity. This is a difference, square this quantity. So minus 8 square 64, minus 4 16, 0, this and this. Right? And same thing you can do it. Minus 2 square 4, 1, 0, 1 and 4. But nothing has happened. We just able to get rid of the negative sign. Let's take one step ahead. Suppose I take the sum of all the values. And sum in statistics is denoted by this sum. This is a symbol for sum. Sum of this squares. Xi minus x bar square. So if you add, it will be 64 plus 64, 128 plus 16, 144 plus 16 again, 160. And here it will be 4 plus 4, 8, 9 and 10. So it is 10. So you are coming closer to some mathematical form. One thing is clear. Where this sum of square will be larger, variation will be larger. Where the sum of square is small, variation will be small. But there are luckily 5 observations in both. Let's say in series 1 you have 100 observations. In series you have just 20 observations. Then obviously where there are 100 observations, this sum will be large. Where there are 20 observations, this sum will be small. So I cannot compare the sum. I cannot compare because the series are having different numbers. That's why we take an average. If there is a class in which there are 100 students, you have marks of all the 100 students, and take the average, you have to divide by 100. And in another section there are 20 students, you take the 20 students, here you have to divide by 20, and you will see averages will almost be same. So if you take the average of this sum, it is just 1 divided by the number. That will give you average. So 1 by n of 160, 32. 1 by n of 10 is 2. So now this is whatever way, whether you are having 5 lakh observation, 50 lakh observation, doesn't matter. You compute this factor. And you have learned in your 10th standard, 11th standard, the formula for variance. And this was the formula for variance basically, which we have learned. Right? So this was the formula for variance, which we have learned in 10+2 standard. And that is called sigma square. Notation is sigma square. And if the power of this difference is 2, then in statistics this is called second order movement, because power is 2. If power becomes 3, then this is called third order movement. And if power becomes 4, then this is called fourth order movement. And these movements, second order, third order movements, fourth order movements, they are helpful in computation of skewness and kurtosis, which I will discuss next. Okay. Now once we know the variance of the data, and you can compare, why to look at standard deviation? It is also having certain kind of logic. For example, if I am given height in centimeters, then if I compute the mean, I have to add all the heights divided by certain constant, so units for mean will also be centimeter. But look at the units of variance. Units of variance will become centimeter square. And if I want to add mean plus minus variance, I cannot do that, because mean is centimeter, variance is centimeter square. They are different units. I cannot do that. That's why we compute standard deviation. Standard deviation is nothing but under root of the variance. Under root of centimeter square will come back to centimeter. So that's why we compute standard deviation, which is under root of variance. That is the logic behind computing variance. Now you can add mean plus minus standard deviation, which we require in many problems, right? Then there is another term which is called coefficient of variation. Now once we know the variance, why to look at coefficient of variation then? Suppose somebody give me the data, one variable is height, another variable is weight, right? Weight is in kg, height is in centimeter. Now, his question is whether height is having more variation or weight is having more variation. Now, even if you compute variance or standard deviation, they will come in different units. One will be centimeter, another will be kg. You cannot compare them. But I want to see whether height is having more variation or weight is having more variation. Right? That's why we compute coefficient of variation. So in such type of cases, coefficient of variation makes sense when we want to compare 2 or 3 more series. They are measured in different units. Then what we do for each series, we compute its coefficient of variation, which is given in percentage. For example, let's say height. I compute the standard deviation of height. I compute the mean of height, and then take the ratio sigma divided by x bar multiplied by 100. Suppose height coefficient of variation is coming out to be 37%. Similarly, I can do it for weight. I compute the standard deviation of weight, mean of weight, standard deviation divided by this. Let's say mean variation is coming out to be, weight variation is coming out to be 17%. Height was 37%. Weight is 17%, which is having less variation, weight. So you can say weight is having less variation as compared to the height. Although they are measured into, because this is a free from units. Units will get cancelled. Standard deviation, same units, mean same units, units will get cancelled. So that's why we compute coefficient of variation. And when we divide the data into two equal parts, the central part is called a median. When we divide the data into four equal parts, then they are known as quartiles. For example, Q, if there is a line, central point will be median. Right from the beginning to the median will be in the center, there will be another point, and from median to the end, there will be another middle point. These two middle points, they are known as basically Q1. Q1, because median stands for 50% observation below this, 50% above this. And Q1 stands for 25% below this, 75% above this. Q1 stands for first quartile. Q3 is third quartile. Q3 is third quartile means 75% above this and 25% below this. These are known as quartiles. Q2 will be nothing but median, which is halfway. Deciles divide the data into 10 equal parts. Percentiles divide the data into 100 equal parts. Okay, and finally, before I ask you a few questions, you can ask me a few questions. This is the last two slides which are very important, skewness and kurtosis. Skewness and kurtosis. Right? And then with all the basics we have covered, then we'll move on to SPSS. Let's look into skewness and kurtosis. Now, why do we need to look at skewness and kurtosis? Skewness and kurtosis help us to take a decision actually, whether we have to apply parametric test or we have to apply non-parametric test. Right? Now, everybody is familiar with histogram. Actually, skewness word stands for lack of symmetry or asymmetrical type of data. Asymmetrical type of data. Right? Now, look, everybody knows histogram. If you have seen histogram, there is one bar, other bars on the left and right side. Suppose your shape of the histogram, there is one bar here. There are three bars on the left hand side and three bars on the right hand side. And if you drop a line from the center and you draw a curve like this, it will seems to be like this, right? And if you drop a line from the center, then what you can observe that area on the left hand side will be same approximately as area on the right hand side. If this is the case for your data, then we say that there is no skewness. Your data is symmetrical. Your data is symmetrical. And there is also a measure for skewness, which is computed, that is called beta 1. It is given in terms of moments, which I was explaining you, third order moments, second order moments. I'll show you the formula also. Right? But if you draw the histogram, let's say one bigger bar is here, then there are three bars on the left hand side, but there are 10 bars on the right hand side, small bars on the right hand side, and curve will look like this. And if you drop a line from the highest point, area on the left hand side is less, but area on the right hand side is more. If area on the right hand side is more, then we say that your data is positively skewed. Your data is positively skewed, right? And if it is other way around, let's say I drop a line from here, area on the right hand side becomes less, but left hand side becomes more. Then we say that it is negatively skewed, right? Now the measure of skewness is called beta 1. SPSS will give you value of beta 1. This is how it is being computed. We know the variance, that is called second order moment. We can also look into raising the power 3 by third order moments, and then compute this quantity under root of m3 square divided by m2 cube. I square this quantity because cube could be negative, it could be positive also. Once you square, it will become positive. Variance is always positive. So it's a under root of the positive quantity. Then I have to assign positive sign or negative sign depending upon the sign of m3. Let's say if sign of m3 is negative, then you put negative sign in front of this figure. If sign of m3 is positive, you put a positive sign in front of beta 1. So your beta 1 either could be greater than 0, negative, If it is positive, it could be less than 0 if it is negative, and equal to 0 if it is symmetrical. Let's say value of beta 1 I compute from this formula, it is coming out to be 0. Then I'll say that there is no skewness. It is a symmetrical data. If value of beta 1 is coming out to be positive, when the sign of M3 will be positive, then it is positively skewed. If beta 1 will be negative, when the sign of M3 will be negative, then you have to put a negative sign, beta 1 will become negative. If the beta 1 is less than 0, so that means it is negatively skewed. Hopefully, the idea about skewness is clear to you, and this is helpful to determine the nature of the distribution, whether it is having a normal or not. Okay. And the final thing is about kurtosis. Kurtosis stands for basically the peakedness of the curve, how peak it is, how flatter it is, or it is in between. We measure by a term which is called peakedness, right? For example, let's say, how do we compute? There is a measure. This is fourth order moment. This is second order moment square minus 3. If you subtract minus 3, again you can compare in terms of 0. So SPSS will do it for all. You will get value of beta 1. You will get value of beta 2. Only thing is interpretation is important. Now, if value of, you look at 3 graphics. This is one graph, this is another graph, another graph. Now drop a line from the center. You can see area on the left hand side is same as area on the right hand side. Same thing is here. You drop a line here. Area on the left and right, they are same. Drop a line here. Area on the left and right, they are same. So if areas are same, that means none of them is skewed. All of them are symmetrical. But shapes are different. This is having high peak. This is having flatter peak. This is in between. So look at the peakedness of the curve. We compute kurtosis. And that is given in terms of beta 2. SPSS will give you value of beta 2. If value of beta 2 will come out to be 0 or approximately 0, then we say that we have a mesokurtic type of graph. It is not peaked, it is not flatter, it is in between. So for this type of curve, it is beta 2 value will be 0. But if value of beta 2 is greater than 0, greater than 0 means it is having high peak. The peak is high. And this type is called leptokurtic distribution. So if it is having high peak, then it is called lepto. Lepto means high. And if value of beta 2 is negative, then this is called platykurtic. Flatter than the normal. Flatter than the normal. So kurtosis, we compute beta 2. If beta 2 value is less than 0, platykurtic. Greater than 0, leptokurtic. Equal to 0, mesokurtic. Mesokurtic is also called normal. And similarly, we compute beta 1. If beta 1 is greater than 0, positively skewed. Less than 0, negatively skewed. Equal to 0, no skewness. So with this background, I'll show you a picture. This is an exercise to you. Can you see A and B lines? Yes, please. Can you see A and B lines?
Yes, sir.
Sir.
So, yeah, okay. Just answer one question. Whether A looks smaller or B looks smaller. Which one looks smaller if you see from your eye? Yes, please. Any answer?
A.
Okay. Somebody says A looks smaller. Let's test your knowledge.
Sir, both are equal, sir.
This is A, this is B. Somebody was saying both of them are equal. Correct. But if you see from your eye, A looks smaller and B looks larger. Why? What is the reason? The reason is very simple. Because A is closed from both sides and B is open from both sides. The human mind also works with the same logic. If you are sitting here listening to me with a closed mind, you will see the same picture. And if you are listening to me with an open mind, the same line will look bigger to you. Right? So life exactly works on the same logic. कहते हैं ना कि भाई अगर आदमी का दिमाग क्लोज होगा तो लाइफ बहुत छोटी दिखाई देगी और अगर आदमी का दिमाग ओपन रहेगा तो वही लाइफ आपको बहुत बड़ी दिखाई देगी. With this, I come to the end of the first session, and now if you have any questions, any queries, you are most welcome to ask. Yes, please. Any question, any query? Up to this, I have covered all basics of research methodology or basics of statistics. Yes, please. Any question? You can ask me, please don't hesitate. After this, I'll start with SPSS. Yes, please. पूछिए भाई.
Sir, you have elaborately explained all the things.
Okay.
I think a person who doesn't know ABCD of statistics can also understand mean, median, mode. That means central of tendency, measurement of tendency, central tendency, and measurement of dispersion.
Right.
I think from last 20 years, I am teaching statistics in home science. So the students who are teaching, learning home statistics, they don't having the knowledge of statistics. They don't know ABCD of statistics. But I always start with mean, median, mode, and SD and quartile deviation. And
Right.
I always tell the students that if you understand clearly mean, median, mode, and dispersion, then you can do anything in statistics.
Yeah.
And I think you have clearly explained basics of statistics. So I am very satisfied, and I can say that I have learned so many things because I probably from these many years I used to teach them practically, not theoretically.
Okay.
So the difference between mean, median, mode, and difference between SD and variance and range, that I could not able to explain them. So I maybe from now onwards I can make them understand the difference.
Okay,
So
very good. Okay. Anybody else, please? Anyone else want to say something? If anything is not clear about scales, nominal scale, ordinal scale, interval ratio, anything, you can ask me before I proceed on to the next topic, please. Anybody want to ask question? You are most welcome. Yes, please. Anyone?
Sir, can I get to the calculation of kurtosis, because I could not take hints of the calculation of kurtosis.
Okay. So kurtosis you want, right? Okay. All right. So this is the calculation of kurtosis. Can you see the slide?
Sir,
Can you see the slide?
the elaborated calculation are there.
Yeah, it is simple actually, because you see, you have to compute beta 2. Beta 2 means M4. Now, how M4 will be computed? I'll show you how. This is power 3, right? And if I raise this power 4, you will get M4. That means the difference, whatever is the difference, you multiply 4 times. You multiply 4 times the difference and then take the sum and then divide by n, you will get M4. So M4 is known to you. M2 is already known to you. M2 is already known to you. That is a variance. Then M4 divided by the square of the variance minus 3. You compute this factor, which is called beta 2. Now, if your beta 2 is coming out to be 0, that means your curve is a normal curve. Mesokurtic we call it. If value of beta 2 will be greater than 0, that means it is having high peak. High peak is called leptokurtic. And if beta 2 is less than 0, then this is called platykurtic, flatter than the normal. So very simple to compute beta 1 and beta 2, right? Just look at the fourth order moment, divide by the square of the second order moments, that means square of the variance. And then subtract minus 3. Why we subtract minus 3? So that we can compare in terms of 0. Otherwise, if you look at the kurtosies of the normal distribution, it is equal to 3. So if I subtract 3, you can compare in terms of 0. So that is the reason we subtract 3, because SPSS will give you value in comparison to 0. So that's why I subtracted 3, so that you can compare with the SPSS output. Is that clear? Yes, please. Yes, please. Is this clear?
Yes, sir.
Yeah. Any other question? Please don't hesitate. We have enough time. I can answer questions, and later on we can. Somebody has written Devrati Ray. Everything was very clear, sir. Okay, thank you very much. Anything, anybody else? Or should I proceed with SPSS now? Yes, please. Should I proceed with SPSS now?
Yes, sir.
Okay.
Yes, sir.
All right. All right. All right. Now, tie up your belts, because once you understand this SPSS, then you can do your calculations yourself. You will not have to dependent on anybody. Now, this is the logo for SPSS, which is now called IBM SPSS Statistics. There are different versions: 15, 16, 17, 18, 25. Now 28th version has come up now, right? So you work in any version, doesn't matter. So how to enter data in SPSS? What is the meaning of SPSS? People call it SPSS, people call it Statistical Package for Social Sciences. Actually, this is not the name of SPSS. The full name of SPSS is Statistical Product and Service Solutions. Statistical Product and Service Solutions. That is the real name of SPSS. Okay? SPSS stands for Statistical Product and Service Solutions. Now, if you look at how to enter data in SPSS and how to import files from other files, that is the task we have to do in next 3 hours. First of all, because we have to take a break at 5 o'clock, so we'll take a break around maybe 10 minutes before that, and then we'll start the session around 5:20, half an hour, and you will be free by 7:20 then, so that we'll manage. Okay, just wait. It is uploading and it just takes some time. Just wait for a moment. Takes around 50-60 seconds. Taking more than the usual time. System is slow, I think. Just wait for a moment. Yeah, it is coming up now. So this is basically in 2009, the IBM has procured this software, and this is called IBM SPSS Statistics. So if you want to quote somewhere, you need to just press cancel here, you will be at the worksheet of SPSS. So this is called the worksheet of SPSS. Is it visible? Yes, please. Is this visible?
Yes, sir.
Yes, sir.
Okay. The question is, in 2009, this entire software has been procured by IBM, and the name is called IBM SPSS Statistics Package. So if you want to quote somewhere, that some research papers, they also need the reference, then you can quote that the data was analyzed using IBM SPSS statistical software version so and so, right? Okay. Now this is the worksheet of SPSS, and there are 2 ways to enter the data in SPSS. One is you can directly enter the data in SPSS, just like we do it in Excel. Second is you can import the data from some other file. So we will do it both the ways. Okay. Now first, if I want to enter data myself, then what to do? Let's say scores of the students are available and I want to enter here. So let's say scores are given out of 100. Suppose first student gets a score of 12, then 34, 45, this, just randomly entering few values. So few values and this. These are the values, right? Okay. Now, by default, Spss has chosen some name because we have entered the data. Spss was not knowing it is a score or it is age or height. So by default, it has taken some name. What was the name taken? Variable 4 zeros and 1. And if I start with, let's say, next variable is height, then it will take variable 402. Next variable is weight, then it will take variable 403, and so on. So it will continue like this. If you compare this with Excel, in Excel you have ABCD here. In SPSS you have variable 1, variable 2, variable 2, variable 3, etc. So that's the only difference between Excel and this. And moreover, if you see in Excel, you have the sheet 1, sheet 2, sheet 3, below corner, left hand corner. But here you have two views only. One is called data view. What you are observing is a data view. Another is a variable view. Now, my actual name for this variable is score actually. How to change this to score? So I can make use of the variable view. You click on to variable view and then the name will appear and change the name from here. Score. This is score. And come back to the data view. You can see the actual name is appearing. The actual name is appearing. Similarly, you can do it for age, you can do it for height, you can do it for weight, and so on. Now, once we have entered only 12, 33, 44, but SPSS has added 2 decimals. By default, the program is such that it will take 2 decimals. It will take 2 decimal values. Although in this case we don't require the decimals, but by default it will take. You go to the variable view, there are decimals here. If you do not require decimals for any variable, you can increase or decrease. For example, for scores, I don't require any decimals. Of course, if you are given 53.5 marks or 60.5 marks, then you can make use of 1 decimal or 2 decimals. But suppose I don't require decimals, make it 0, so your decimals will go. Right? But generally, by default, it takes 2 decimals. So let me have a default value. Okay. Now, if I start entering the numeric data, I started with 12, 33, 44. SPSS automatically understand that this is a numeric variable. You can check. Go to the variable view. It has taken the type as numeric. It has taken the type as numeric automatically. But suppose I start writing here ABCD. Then which is not numeric. If I start writing ABCD here, it is not numeric. Then SPSS will automatically take this as a string variable. What is a string variable? Which is not a numeric variable, like address, like gender, male and female I am writing. Instead of 1 and 2, I am writing male, M-A-L-E, female. Let's try that. Let's say I write male. So it has taken the male. Once it has taken the male, you go to the variable view, it will not show you that this is numeric. It will take this as a string variable. You see, automatically it has taken this as a string variable. Right? Now, let's say first is a male and second one is a female. Now, you can hear a beep here. You can hear a beep. You can hear, it is not taking female. Why it is not taking female? Have you listened to the beep? Yes, please.
Yes, sir.
Yeah, the beep was because it has simply taken male, but if I start taking female, LE, it is not taking. Why? What is the reason? The reason is simple. If you go to the variable view, what is the width? Width matters. Width of a numeric variable was 8. But what is the width of a string variable? It is only 4. And if you go to the data view, male is having just 4 words, M-A-L-E, but female is having 6 words, F-E-M-A-L-E. But width was 4, so it has just taken first 4 words, but you can increase or decrease the width from here. I can also make this 8. You can make this 80, doesn't matter. You can simply write this 80 if you want to enter address. You can write 800 even, doesn't matter. If I want to write 6 lines, no problem. So let's make this 8 and go back to the data view. And now if I write LE, it is taking. So that was the reason it was not accepting female. You have to increase the width. Okay. Now it is very difficult to enter male and female. Let's say I have 500 students, and in front of that, if I want to write down male, female, male, female, male, female, it's very difficult. But I can always choose a code. Let's say code 1 for male and 2 for female. Then task will become easy. Let's say male code is 1, female is 2. So in your entire data, there are some males, some females, like this. Right? There are some male. This is by default. This is something like 2. Okay. So there are some male and some female. 1 stands for male and 2 stand for female. Now, how SPSS will come to know that 1 is male and 2 is female? So there is a flexibility in SPSS. You can assign labels. You can assign labels or value labels. We call this as value labels. Right? Now, how to assign this? Go to the variable view. And this is our variable number 3. This is called values. You click here, then 3 dots will appear. You click onto these dots. And then this type of window will appear. Let's say 1. 1 stands for male. 2. 2 stands for female. So I have given the labels. These are called value labels. So that SPSS will understand that 1 is male and 2 is female. Press OK. And then come back to the data. You can see 1 is replaced with male and 2 has been replaced by female. Now, if I want to see what is 1 and 2, then there is a toggle switch which has been provided at the top. This is called value label switch. If you press this, you can see 1 and 2. If you again press this, you can see male and female. Hopefully you can see, right? But your answer, whenever you want to make a table, if you do not assign labels, then your table will appear how many times 1 is appearing, how many times 2 is appearing. And you may forget what was 1, what was 2. But if you assign the proper labeling, now it will give you a table, how many males are there, how many females are there. Okay, so readability will improve. Now, do you think I require this variable number 2 now? I don't require variable number 2. I have already given this. So if you want to remove any variable, let me just repeat, if you want to remove any variable which is unnecessarily, then you click at the top, not here, but click at this top. That means heading. Then this entire column will become yellow. And then you right click here and then press this clear and it will go out of the picture. This is going out of the picture. You're able to delete it. Same thing you can do in Excel also. And if I want to again insert, then variable is always inserted to the left hand side. Left hand side, wherever you mark your column. Suppose I mark this column and want to insert certain variable. Variable cannot be inserted to the right. It is always inserted to the left. So how to insert? This insert variable. Now one variable is inserted. You can change its name to something, age. Let's say you forget age. And if you want to delete it, you can just clear it. And now we have 2 variables. One is score, another is gender. So I can give this name as gender. So you have entered 2 variables. One is score, another is gender. Right? Now another important point. Another important point is sometimes we need to divide our data. We need to divide our data into different categories. For example, this is score. Somebody may be interested to see those students who are very poor scorer, whose score is very poor, like less than 30. That means they require extra attention, right? And maybe I want to make 3 categories of this data. Let's say those students who are scored less than or equal to 30 marks, then those who are scored between 30 to 60 marks, and those who have scored more than 60 marks. I want to make 3 categories of this data. Let's say I want to make 3 categories of this data. So how to make it? Very simple. So we want to transform this variable basically to a new variable, old variable to a new variable, and wherever the value will be less than or equal to 30, it will be replaced by 1. Please note down, less than or equal to 30, code will be 1. 30-60, code will be 2. Greater than 60, code will be 3. This is what we want. Right? Now, if you make a transformation, then there are options in transformations. You can transform this variable to a new variable. So this is your old variable. New variable means wherever the values are less than or equal to 30, they will be replaced by 1. For example, 12 will be replaced by 1. Then 21 will be replaced by 1 because they are less than 30. And between 30 to 60 will be replaced by 2. 33 will be replaced by 2. 44, then 43, 44, 54 and 31. They will be replaced by 2. And if the value is more than 60, it will be replaced by 3. For example, this will be replaced by 3, this will be replaced by 3, and so on. You hopefully you are following what I'm saying, right? So let's make 3 categories of this data. We have to go for the transformation. So this is a transform. And in transform, there are 2 options: recode into same variable, recode into different variable. Recode into same variable, recode into different variable. Now, caution here is, please do not use the first option of the same variable. Otherwise, you will be losing this variable. It will be replaced by 1, 2, 3. Always go for the second option so that your original data is not lost. And SPSS will generate another variable that will transform these 2 codes. So use this recode into different variable. Now another window has opened. It says, what is your input variable? Input variable means the variable which you want to transform. So we want to transform score. So when you start doing any operation in SPSS, 2 windows will always open. Sometimes more than 2 windows will open, but 2 windows will definitely open. This is called the left-hand window, and this is called the right-hand window. Left-hand window will show you all the variables which you have entered. All the variables which you have entered. So we have entered 2 variables, score and gender, and it has shown the 2 variables. If you have a list of 50 variables, it will show you all the 50 variables. Then maybe you can see in this box only 20 or 25, first 25. Then this type of button will automatically appear here. And if you click onto that, you can scroll down and you can see the 21st, 22nd, and all the 50. Right? Now, we want to make transformations for score. Now then you shift only that particular variable to the right-hand window on which you want to perform transformation. So we will want to make transformation for score, click and then this is your input variable. Now it is asking what is your output variable name. So name you have to give here. Let's say I give this name as score code. That means it has to be a single word. I cannot write like this. Of course, underscore is allowed. You can write this. But if only a single word is required in variable name. I'll explain you this thing later. Please don't forget to press this change. Very, very important. If you press this change, then SPSS. Now what is this? How to read this? SPSS will generate another variable where it will be generated next to your vacant cell. So next vacant cell is here. So automatically this score code name will appear here. That will transform your score to score code. So what do you want? Only you need to replace the old values. Old values means values which are less than or equal to 30 by 1, between 30 to 60 by 2, and more than 60 by 3. So press on to old and new values. Old and new values. So if you click on another window will appear. So this window says, what do you want to do? So there are options here. One is option is for range. Range means 10 to 20. I mean, I can write 10 here, 20 here. That will make one category. That is all about range. But if you have open-end classes like less than or equal to 30 or greater than 60, then range will not work. Then there are two other options. This is up to the lowest point and this is highest and above. So first of all, click up to lowest point. Our lowest cutoff is 30, less than or equal to 30. Our new value will be 1. So I'm assigning new value. And how the SPSS will read, lowest through up to 30 will be given code as 1. This is what we wanted. Lowest through up to 30 will be given code as 1. Then next value is 30 to 60. So this is range 30. It's a range 30 through up to 60. The new value is 2. And this new value 30 through 60 will be given code as 2. Now some of you may be wondering that 30 is appearing here also and 30 is appearing under code number 2 also. If there is exact value 30, where it will go? It will go to code 1 or it will go to code 2. Very important point. Now please remember, there is no overlapping in SPSS. SPSS never overlaps. Never. Then where this 30 will be counted? And here is where this 30 will be counted. Answer to that. Please note down. Wherever you are specifying your cutoff for the first time. Let me just repeat. Wherever you are specifying your cutoff for the first time, every value up to that point will be taken care of. So we have specified 30 for the first time under code number 1. So what does this mean? That up to 30 is taken care of by code number 1. Up to 30 including 30, because 30 was the cutoff. It was taken care of by code number 1. Even if you start from 28 to 60, even if you start from 15 to 60, but up to 30 is taken care of. It will automatically start from 30.0001 onwards, right up to 60. You follow my point? Even if I write here 25 to 30, 60, doesn't matter. SPSS again will start from 30 onwards, because up to 30 is taken care of by code number 1. So there is no overlapping in SPSS. Right? Next, highest cutoff is our 60. So I can specify 60 and above. So new value will be 3. So 60 through highest will be given code as 3. So what SPSS will do, it will convert the entire this data into 3 categories. The name we have already given score code that will appear here, and that will convert this into 1, 2, and 3. So continue here. Okay, press OK. And now you will see the analysis. It is done. 1, 2, and 3. It has appeared next to the gender variable, next to the vacant cell, next to which is vacant cell. So now you can see that 12 is less than or equal to 30. 33 belongs to 2, 30 to 60. 44 belongs to 2. 77 belongs to category number 3, greater than 60, and so on. Now you can label them. Just we have done the labeling for male and female. So you know how to assign labels. Go to variable view. In score code, you click on the values, and let's say 1 code was less than or equal to 30. 2 label was 30-60. Our 3 label was greater than 60. Add. Press OK. Come back. Now you can see. Very clear picture. 12 less than or equal to 30. 33, 44 lies between 30 to 60. 43 between 30 to 60. And all these are greater than 60. So this is how we can assign different kind of score codes, right? Then before we take a break, we will take just 10 minutes early. Go to the variable view, and in variable view, if you see, there is an option here which is very important, which is called measure. That's why I measured scale right in the beginning. I discussed scale right in the beginning. Measurement scales, nominal scale, ordinal scale, right? If your data is continuous like score or something, it is always considered as a scale, interval and ratio, both. So in scale means interval and ratio, both covered under scale. But for nominal and ordinal, you need to specify. For example, look at this variable. There are three options for every. You can either click scale, scale means interval and ratio, or you can click onto ordinal, or you can click onto nominal, right? These are for categorical data. Now look for the gender. Gender is nominal or ordinal? Yes, please. Gender is nominal or ordinal? Yes, please. Gender, nominal. Very good. So it's already says nominal. Suppose if SPSS in some version it says that it is scale, then you have to change this to nominal. From here you can scroll and change this to nominal, right? Now next variable is your score code. It is having less than or equal to 30, then 30 to 60, more than 60, 1, 2, 3. Is it nominal or ordinal? Yes, please. Nominal or ordinal? Ordinal. So I must click on to ordinal here. So this is very important, right? So, and finally, how to save the file? Very simple to save the file. Let's say I have made all the changes, but when you send this file to me, these two are very clear that this is gender, this is score code. I can read from the labels that one is male, two is female. I can read it, and I can also read these categories. 1, 2, 3 stands for what? But I don't know whether it is a score of physics, whether it is a score of chemistry, or what. I don't have any idea, right? You go to the variable view, and you can specify the name here, that this is a score of what. There is a label here. You can specify the label so that somebody who is getting the file for analysis will come to know that this variable stands for what. Let's say these are scores of the students. Let me give this label, scores of the students. Then if you go to the variable view, nothing will happen here. But if somebody read the file and go to the variable view, he will come to know that this variable stands for the scores of the students. The next is a gender variable where 1 is male and 2 is female. Next is an ordinal variable where score code has been divided into 3 categories. So everything will be clear. Once these things are clear for each and every variable, you can go to file, you can go to save as, and in save as, let's say I want to save this on the desktop, then you can give the file name. Let's say my file name is temp, and simply press save. Then your file will be saved on the desktop. Name will appear like this. For example, one of the file in SPSS, this is, it will show you that this is SPSS file, RT_data copy. And automatically the extension will be shown as your name is file. So your file name will appear temp.save. Temp.save. SAV stands for that it is an SPSS saved file. So this is how you can save the file. So we will take a break and we will assemble after half an hour. You have enjoy a cup of tea, or maybe I'll also enjoy a cup of tea. If you have any question in the meantime, you are most welcome. Please, I'll continue from here. Any question in the meantime? If you have, please, any question? Yes, please. Mehta madam, if you have any question.
Yes, sir. We have given one assignment today.
Yeah, I'll discuss that in my last topic. Maybe last half an hour I will discuss.
Oh, okay. Thank you, sir.
Anything else?
No, sir.
Up to this, I think whatever I have explained, most of the things should be clear. If you still have any doubt, you can ask me.
No, sir. Thank you.
Okay. So, Dayashankar ji, are you there?
Yes.
Dayashankar? Yeah, we can take a half an hour break.
Okay, sir.
And we will come back at 5:20.